So now let's sketch y is less than 3x plus 2. We know how to draw the line. We go up 2, that's the y-intercept, and the slope is 3, or up 3 and 1 right. Now the key is we don't use a solid line, we used a dashed line or a dotted line because of the inequality symbol. It's not including the equal sign, it's just less than. So when you say y is less than this line, we shade south of this border. So this towards the right is a solution region. So we know that we have this boundary line based off y equals 3x plus 2. And let's substitute the x value. Y equals 3 times negative 1 plus 2, which is minus 3 plus 2 is minus 1. This means that when x is negative 1, we'll just say here, the y value should be negative 1. It's right on the actual boundary line. Now this diagram is not to scale. We should have made this graph a bit steeper, but we can see that when x is negative 1, the y value should be negative 1 in the boundary line. And when a point is actually on this dashed line, we say no, it's not in the solution region. The dashed line does not count. If this was a solid line, the answer would be yes, but in this case, it's no. Let's now sketch a solution region involving quadratics. When y equals x squared minus 4, we know how to draw a happy face. Shift it down 4 units. 1, 2, 3, 4. So we have a nice happy face that looks like this. It's called a parabola. However, we should not make this solid because we have an inequality statement without the equal sign. So the proper graph should be dashed. So we draw a nice dashed parabola. And when you say y is greater than or above the parabola, we shade everything that is above as a solution region. Let's now sketch this quadratic inequality. When focusing on y equals negative x squared plus 9, we just rearrange this. We know this is a sad face quadratic. Shift it up 9 units. So we write 9 here, and it looks like this. And for this inequality statement, we include the equal sign, so this line indeed remains solid. And when we say that y is less than or equals to this quadratic, we always shade below. Think of this as the border, and we're shading in USA. So this here is the solution region. Let's practice some algebra. When we have 2x equals 8, we divide both sides by 2. So x equals 8 divided by 2, which is 4. Similarly, we can solve for x when dealing with inequalities by treating this inequality symbol much like an equal sign. So let's divide both sides by 2. We get x is less than 8 divided by 2, which simplifies to be x is less than 4. However, the rule is that when we multiply or divide by a negative number, we need to flip the direction of the inequality statement. So let's divide by negative 2. When we divide by negative 2, the negative 2 cancels, so we get x on the left all by itself. But we flip the inequality because we're dividing by negative. So we change the direction, and we have 8 divided by negative 2, which becomes negative 4. So the answer is x is less than or equals to negative 4. By the way, we don't have to flip the direction of the inequality statement if we leave it alone and just move terms over. When we move the negative 2x to the right, the sign flips and becomes positive 2x. And when we move the positive 8 to the left, it becomes a negative 8. Dividing both sides by 2, we have x is less than or equals to negative 4. This here is the same as x is less than or equals to negative 4.